Okay, the last thing we're going to cover in this class is the logarithmic function. Again, we're going to look at a base, and the base has to be greater than 0, and the base cannot be equal to 1. When we said that we had a function x is equal to b raised to the y, this is true for a logarithmic function if and only if y is equal to the log base b of x. So y is the exponent, and when you apply log, you get the exponent all by itself. The logarithmic function is the inverse function of the exponential function. So like adding was the inverse of subtracting, and dividing is the inverse of multiplying, log is the inverse of being an exponential function. How would you find the exponent for the base 2 if the answer is 3? In other words, if I had 2 raised to some power and the answer was 3, how could you possibly solve for x? How could you get x alone? The logarithmic function takes in the answer and gives you back the exponent. So if I wanted to rewrite the following statements in a logarithmic form, I would say that 3 raised to the 2 equals 9, a very true statement, and the log base 3 of 9 is 2. So when you have the log applied, the base that was being raised to the exponent is the base for the log. And the answer is what you put into the log. And what you get back all by itself is the exponent. Let's try that again. If we wanted to apply the log to this, we would have log base 10 of 1,000 is equal to 3.